Okay, in this video, we're going to be talking about the Hamilton method for seat distribution. And this method actually has multiple steps, and here's the list of the steps. We're going to talk about the ideal ratio, class quota, the initial Hamilton appointment. We're going to apply the method itself, and then the final Hamilton appointment. So if you need to pause the video just to kind of copy all this down, let me encourage you to do so. Let's go ahead and get started. We have a problem here where we have North Georgia Wilderness Representatives. There's 25 members, and there's 4 districts that make up this area of North Georgia that this representative party makes up. So there's 25 members, and every year they have to assign new representatives. Okay, so what's things that we need to kind of highlight? First off is the 25 members. Okay. Notice that each population has a different population. All right, things to just take into account. So step 1, if you remember going back to the other slide, is finding the ideal ratio. Now the ideal ratio can be found, and I'm just going to use this as IR, ideal ratio. It can be found by taking the total population, ran out of room here, and divide it by the number of seats. And the number of seats will always be given to you in a problem. All right. So our total number of people, our total population is going to be 116,000. So 116,000 is our total population. And we're going to take this and we're going to divide this by 25 members. And when we do that, we have an ideal ratio of 4,640. So our ideal ratio is 4,640. Okay, that's step 1. Step 2, if we go back to the other slide, is figuring out the class quota. Now the class quota, which I will use as CQ, is taking the class population and dividing it by the ideal ratio. Now the class population, the word class itself, I'm going to use this kind of loosely. And what it means is all the different groups that you have. So in this case, the classes represent all the districts. So I'm going to take 23,000 and I'm going to divide it by the ideal ratio, which is 4,640. And my class quota will be 4.95689, and it just keeps going on. So what I'm going to do is I'm going just to cut it at the hundreds place. Now you might be saying, can we round it? Don't round. Just cut it at the hundreds place. All right. And so what I'm going to do is I'm going to go ahead and figure out the rest of the district's class quota by dividing each population by 4,640 or 4,640. And we're going to get going with that. And there you have all the class quotas. So let's go to the next step. The next step is the initial Hamilton appointment. Okay. The initial Hamilton appointment is what would be the initial results, meaning the first findings, if we just went off of this information here. Now I'm going to clean this up a little bit because hopefully you already have this in your notes. So I'm going to create a new column, and it is the initial Hamilton appointment. And I am abbreviating for space here. Now, the rules under the initial Hamilton appointment is this, and I'm going to write this here, is that you round the class quotas down. Regardless of where they are, you always round down. So this 4.95, well, you're used to rounding up, but since it's not actually at that 5, you're going to round it down to 4. Here, you're going to round down to 6. This one here, you're going to round down to 5. And lastly, this here, you're going to round down to 7. And you're going to total your numbers here. So when I total my numbers, I end up with, I believe it's 22 members. Okay. Now this number here, we want to be 25, but unfortunately it's not going to be. All right. If it did meet 25, then obviously we would stop and we'd move on to our next problem. But unfortunately, it doesn't. So now we have to apply the actual method. And under Hamilton, Hamilton states this, is that whoever has the biggest decimal will receive the seat. Now, notice that we are 3 short. We're at 22, we need 25, so we're missing 3. So what I'm going to do is I'm going to take all my class quotas and I'm going to determine who has my largest decimal. Well, that's District 1. So District 1 would get a point. Okay. If I keep searching, I notice that District 3 has also a large decimal, so this right here would also get a point. So we're going to add 1 to there. And lastly, District 2 has the third largest decimal, so they're also going to get a point. Now I'm going to stop at 3 because that's all I need. Okay. So if this number was like at 2, then I would only look at the top 2. But since I need 3, I'll take the top 3. So now for our final Hamilton appointment, which this is where we're at, the final Hamilton appointment. How will all these seats be divided up? District 1 will end up with 5. District 2 will end up with 7. District 3 will end up with 6. And then District 4 will stay at 7. So if we did this correctly, this would add up to 25, and I believe it does. So we're finished, and we are done. Okay, so hopefully you guys understand how to do this. So we're going to go ahead and jump into another problem. And it's very similar to the last problem, except I just made one change. And that was I made District 4 to be a lot bigger than it was in the previous problem. Okay, so that means I have a new total. I'm still dividing by 25 because that's what the problem states. And my new ideal ratio has changed to fit 5,040. Now, also remember that in order to find the class quota, you had to take each population and divide it by 5,040. Okay, so from here, we're going to go ahead and figure out the initial Hamilton appointment. And if you remember, the initial Hamilton appointment is to round all your class quotas down. So this 4.56 gets rounded to a 4. This will be a 6. This will be a 5. And this will be an 8, even though it's so close to 9. So when I add all this information up, let's see, that's 4, that's 10. I believe that is 23. Okay, remember we're looking for 25 members, so we are going to be 2 short. Now, remember the concept under the Hamilton method, and that is you go off of who has the biggest decimal and you work your way down. So 8.92 has the largest decimal, so I'm going to give a seat to them. And since I'm only 2 short, I just need to find one more, which will be District 1. They will also get a point. Now remember that these points gets added to the initial Hamilton appointment. So that means our final distribution of these seats would be 5 for District 1, District 2 and District 3 stay the same, and lastly District 4 will be 9. So if I add all this up, I believe I get 25, and I do, and so I'm done. So if you have any questions, please let me know the next time you see me. Thank you.